This presentation is the last in our course, and I wanted to just take some time to review some of what we've learned. So this is called Choosing the Right Tool, and that's really what this course is. It's teaching you a bunch of tools to know how to handle different research situations. So what we're going to do here, a little overview. Now we're going to go back over some of the techniques we've learned over the course of this term, and think about when to use these techniques and find the right tool for the job. So I've categorized these different techniques that we've learned into these four basic groupings. We have description, where we're going to take a large amount of information. You think about all the data in a column of a spreadsheet, for instance, coming up with ways to make sense of all that data so we can kind of summarize what they mean. So that's purely description. We're going to look at inference, which is making the leap from sample observations to observing characteristics within a wider population, so making that generalization. We learned techniques that allowed us to compare groups. So we looked at situations where we have two groups, difference of means test, for instance, or multiple groups, to identify differences between them and see if those differences could be generalized to the population. And then we studied techniques of association, looking at how maybe two characteristics in a sample might be related, which is important when we're trying to demonstrate causality, when we're looking for evidence of a causal relationship. So let's start with description. We learned about different measures of central tendency and variability, and we had to look at different ones when we're considering categorical. Recall that categorical variables are the nominal and the ordinal variables, while continuous variables are the interval and ratio level variables. With the measures of central tendency, we learned about the mode, the median, and the mean. And for variability, we learned about range, different ways of carving up a distribution that's ordinal or nominal. We could look at percentiles for nominal variables, but with ordinal we could look at deciles, quartiles. We learned about the interquartile range. And then with continuous variables, we learned about the standard deviation and the variance. Some of the techniques we learned using the software we were using, SPSS, and we could certainly use other software to accomplish the same things. Generating frequency distributions, looking at the breakdown of different categories with categorical variables. And we used descriptive statistics to study those different measures of central tendency and variability for continuous variables. And we learned different types of graphs that were appropriate to those different levels of measurement. The nominal and ordinal we show with pie and bar charts. And the continuous variables, we use histograms typically to examine the distributions and look for where the measures of central tendency might fall. This also allows us to examine the shape of the distribution, which was important when later we started studying the normal curve, for instance. Inference is another big part of the course. To really understand the different tests that we did in this course, we had to get a foundation in probability theory, understanding what this normal curve means, for instance, and then using that to understand the standard normal curve, which is the z distribution. So inferential statistics is about hypothesis testing. Usually we have a null hypothesis where the claim is that something cannot be generalized to the population from the sample. So we might observe a mean or median in a sample, but how confident can we be that that's also the mean or the median of the population, for instance? So the null would be that we can't generalize. We don't have enough evidence. The alternative is that we can generalize. So the sample characteristics can be generalized to the wider population. So where probability theory comes into that is this question: what is the probability that a sample characteristic is also a population characteristic? the inferential techniques we learned were using the z-test to make inferences about single groups if they are in large samples, which is defined as over 30 in statistical criteria. T-test for smaller samples, where we use the degrees of freedom to adjust the distribution to the size of the sample. So we can determine whether or not sample mean or median or mode, or if we're looking at measures of variability, could the standard deviation be generalized to the wider population, etc. So we're determining if those single group measures of central tendency or variability could be generalized using some of those inferential techniques. And then we go into multi-group differences, and you'll notice I categorize this into a whole different set of questions. So we have a bunch of techniques we've learned that allow us to compare groups and identify whether or not differences exist. Now, when we do research, we can observe differences in samples, but we're not just content to stop with the sample. We want to know if what we're seeing in the sample is indicative of what's happening in the wider population. So we're using inferential statistics to examine group differences. So when we have two groups, when we're looking at the mean, for instance, we can use the t-test, the difference of means test, to compare two groups. Maybe we want to look at whether or not men and women have different levels of income. That's two groups. It's a continuous variable, so that would be appropriate there. Sometimes we want to look at categorical differences. We used a lot of the general social survey data for those types of questions. So for instance, do men and women have different attitudes or opinions about gun control? Yes or no? So that would be a categorical variable rather than a continuous one. So we'd use a difference of proportion test, which uses the chi-square distribution. We also used that non-parametric test for multiple groups. Now the chi-square is nice because it applies to either two or more categories or groups. So it's a very versatile test for the non-continuous categorical, nominal, and ordinal variables. When we're comparing multiple groups that are continuous, we want to compare, for instance, three different racial groups, white, black, Asian, or other. We could use ANOVA for that to compare, say, income levels once again. So we'd have to use, we couldn't use the t-test because that's only for two groups. If we have multiple groups, we'd have to use the ANOVA, the analysis of variance f-test, which uses an f distribution. So really, remember at all these, we're going to be using the same basic inferential hypothesis tests. The null is we cannot generalize. So even if we see differences between the groups in the sample, the null is that we can't generalize those differences to the population. The alternative is yes, we can. So if we do see differences in our sample, in our data set when we do our analysis, the inferential test, the appropriate inferential test, will allow us to determine whether or not we can confidently generalize to the population. And so we looked at different levels of confidence. Do we want to be 95% confidence, 99% confidence, etc. And all of that came to us from our study of probability theory. Okay, so moving on, after group differences, we studied association. These techniques are important because they allow us to study causality. Remember, though, that causality has three criteria. Association is just one of them. So, when you hear people say that correlation is not causation, what they're saying is we've only hit one of the three criteria. We have to also establish non-spuriousness and time order. A lot of research really does a poor job of dealing with time order because it's really difficult to collect good longitudinal data. And the techniques for longitudinal analysis are a little more complex than we're able to get into in this course. We did learn a little bit about non-spuriousness and how to handle that with our statistical techniques. So correlation, This is the association technique we use when we're just looking at how two variables are related to each other and we haven't really identified a cause or an effect. Regression analysis, we do have to identify what the x and the y are. Right? When you think of the x and y axis in a scatter plot graph, we have to have some idea of what's causing what. So for instance, if we're looking at countries and we're trying to predict their fertility rates, remember we used the level of education among women as a predictor, as a cause. Multiple regression helps us deal with non-spuriousness, so we can maybe add more variables into the equation. So if we're predicting fertility, and we think that from our regression analysis that the level of education for women is a good predictor, we can also take into account some other possible predictors of the fertility rate, such as the level of income in the country or other factors. So when we look at the relationship between something like female education level and fertility, we can say we're also controlling for other causes, and that is helping us establish non-spuriousness. Right, so those are the main techniques. We also looked at the situation where we've got unstructured text. How do we analyze data when it comes to us in the form of a document? There's no numbers involved, not like a transcript from an interview or a newspaper article. What do we do in this situation? Because most of the techniques we've learned are really appropriate for quantitative data. So what we learned in this course were ways to turn unstructured qualitative text into a form that we're familiar with using quantitative variables in a spreadsheet. So we used thematic coding, which we use this dummy coding technique for the presence or absence of characteristics. So when we studied the unstructured answers teachers gave for why they went into teaching, we found codes like, now they love kids, or they like the schedule. And if we read one of the responses and we saw those characteristics, we would code a 1. And if they weren't there, we would code a 0. And by the time we were done looking at all those responses, we had a full spreadsheet of 0s and 1s. And the nice thing is, once you've got those 0s and 1s coded, you can go through and analyze the results using all the other techniques we've been learning about: association, inference. We can look at descriptive statistics, and so on. We can look at crosstabs. So content analysis puts it all together. It's the application of thematic coding to text-based messages. So we can look at unstructured text in a more systematic way. Right, so those were the basic things we've learned throughout the semester. I hope this review will help you kind of synthesize all that material and give you a little bit of reassurance that you now have a good set of skills that will enable you to do some good basic analysis. And that's an important part of the research process. So thanks for watching this, and take care.